here's where we got interrupted on that last video. I apologize. But let's just refresh real quick. So it's given that WT and XV are parallel to each other. We have also said that angle XWT is congruent to ZVR, these two right here. So that is also a given statement, just as where I left off. I can also say that, let me erase it here. Because WT and XV are parallel to each other, I can say that TWX and VXY are also congruent to each other. And that is because angle TWX is congruent to angle VXY, and that is because corresponding angles are congruent to each other when those lines are parallel. Now, I'm eventually working my way to say that that these two guys are parallel to each other. So now that I have made this statement of corresponding angles, I'm going to make the statement that angle, where am I? No, I'm not going to make that statement. XWT and YXV, yes, those are corresponding angles. Now I can make this statement that YXV, yeah, I'm right. Okay, yeah, I'm good. All right, so now I can make the statement that angle ZVR is congruent to angle VXY because of the transitive property. I wrote this incorrectly, so it kind of got lost there. But that's transitive property. Does everybody see that? I should have written TWX, or excuse me, XWT. That would have matched. So then transitive property would have stuck out at me. And now I can say that XY, since I made this statement that ZVR is congruent to VXY, now I can say that those lines are parallel because of corresponding angles converse. Okay, so that's how I would prove that statement. All right, let's take a look at number 12, making sure that you can see this one. All right, so here we go. Again, I'm going to list out the numbers, the steps 1, 2, 3, 4, 5, 6, and 7. 1, 2, 3, 4, 5, 6, and 7. I know that JL bisects angle NKH, and that's a given statement. Now, what I can do here, I don't have to list every given statement, but I know right away, right after another. So I don't lose my train of thought. What I might say is that if JL is bisecting NKH, that means that angle 1 is congruent to angle 2. And so I don't want to lose track of that. So I'm going to say that angle 1 is congruent to angle 2. And why is angle 1 congruent to angle 2? Because the definition of angle bisector. Now I can finish my statement and say JL is parallel to FI, and that's a given statement. So if JL is parallel to FI, I want to keep my eye on the prize here, that I'm proving angle 1 is congruent to angle 4. So if these lines are parallel, I know that 2 is congruent to 3. So I'm going to put angle 2 is congruent to angle 3, and that's because alternating interior angles. Okay, so now that 2 is congruent to 3, I know that 1 is congruent to 2, and I know that 2 is congruent to 3. Now I can say that angle 1 is congruent to angle 3, and angle 1 is congruent to angle 3 because of transitive property. So if angle 1 is congruent to angle 3, I know that angle 3 is congruent to angle 4, remembering the whole time that I'm trying to get here to angle 1 is congruent to angle 4. So now I can say that angle 3 and 4 are congruent, and angle 3 is congruent to angle 4 because vertical angles vertical angles. And now I can use transitive property again and say that angle 1 is congruent to angle 4. Angle 1 is congruent to 3, 3 is congruent to 4, then angle 1 is congruent to angle 4, and that's the transitive property. Okay, so that's number 12. All right, let's take a look at 13. And again, the more we do these together, the better you become noticing your statements and your reasoning. So here I am to draw it out. I just want you to see how you do it. All right, so obviously first step, 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. All right, so here we go. I know that P is parallel to Q. That's given. I know that L is parallel to M, and that's a given. All right, now I want to keep my eye on the prize that 2 is congruent to 5. So what I may start with, if I know that P and Q are congruent to each other, what I can start with, P and Q, hang on, P and Q. All right, so I can say, there's a lot of statements. I can say that angle 5 is congruent to angle 3. And that is corresponding angles. Okay. Step 4, I can say 2 is congruent. I can say that angle 2 is congruent to angle 3 because these lines are parallel. So I can say that angle 2 is congruent to angle 3 because of alternating interior angles. And now I can say that angle 5 is congruent to angle 2 because transitive property. So the big deal is making sure you don't lose how we get, that final statement, getting our eye on the prize there. All right, so now let's take this big one. Hopefully you're pausing these as you go through so we can see if we have the same thing. All right, okay. This looks good. All right, so here we go. 1, 2, 3. I'm just going to pre-number because I don't want to get points taken off. 9, 10, and 11. I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Whew, that makes me nervous just because how many spaces there are. All right, so let's start here. AC is parallel to DF. Why? It's given. So I'm going to look at my picture. So I know that these two guys are congruent to each other, so I may just want to see that. And I know that angle 1 is congruent to measurement of angle 4. Measurement of angle 1 is congruent to angle 4, and that is a given statement. All right, so if I know that angle 1 is congruent to angle 4, and I know those guys are equal. Okay, so here's what I see. I see that these are parallel, and I can see that DEB, this angle right here, is congruent to CBE, this angle right here. So watch what I'm going to do. I'm going to say that the measurement of angle DEB is congruent to the measurement of angle CBE. And that's alternating interior angles. Okay? Now, what that allows me to see is alternating interior angles, that they're congruent to each other. Now, I'm going to say that angle 1 plus angle 2 equals angle DEB. Angle 1 plus angle 2 equals DEB, and that's angle addition postulate. Okay? Now, by that same respect, I can say that angle 4 plus angle 3 is equal to CBE. So now I'm going to say that the measure, I should have put measures up here. Measure of angle 3 plus a measure of angle 4 is equal to measure of angle CBE. And that is also the angle addition postulate. Okay, so now what I can say, now that I have my angle addition postulates, is since DEB is congruent to CBE. I know these angles are congruent. I can now say that the measurement of angle 1 plus a measurement of angle 2 equals a measurement of angle 3 plus a measurement of angle 4. And what allows me to say that? Substitution allows me to say that. Okay? And now going back, and this is an angle 3, I know that angle 1 and angle 4 are congruent to each other, right? So we've already introduced, we know that's my given statement. So now what I can say is I can say that the measurement of angle 4 plus the measurement of angle 2 is also equal to the measurement of angle 3 plus the measurement of angle 4. And all I did there is I substituted 4 and 1 from way up there. So that is also the substitution method. All right, now I can say that the measurement of angle 2 is equal to the measurement of angle 3. And how did I do that? I used the subtraction property. I subtracted the measurement of angle 4 from both of those sides. So now I go from measurement, now I can say angle 2 is congruent to angle 3. And that is my definition of congruence. And then angle 2 being congruent to angle 3, I can say AE is parallel to BF, and angle 2 is congruent to angle 3 here because of alternating interior angles. I'm missing a step somewhere, but that looks good to me. If you find out where I went wrong, let me know. And it could have been done in only 10 steps. So that's what number 14 looks like. All right, we're getting long on our video. Okay, so see if you can do number 15, and then I will check it. For time's sake, you hopefully have enough practice, and either we'll do this one in class or come see me in tutoring so I can check that out for you. Good luck.